Hey, we're going to walk through the first 2 pages of the Intro to Polars Day 1 notes. So here we are. It says, congratulations, you have been appointed as the new city planner of Mathville. Your goal is to devise a system to name, that means give an address to all the locations in the city relative to Town Hall. Think of a system you can use to name the locations. Be creative. You can use ideas you have seen in mathematics, games, nature, etc. So now I'd like you to pause the video, see if you can think of your own way to give names or addresses to all the locations. There's 3 locations here relative to City Hall. And after you spend a little time with that, restart the video. So I hope you came up with some creative ways to name the locations in City Hall. If you flip to the back side, you'll see 2 conventional ways that we can do this. So the first is using our typical reference system, which you've been using for a long time, which is the Cartesian coordinate plane. You can set up a reference system to help us name the locations. So in this system, we have 2 axes, the x and y axes, and then along the horizontal axis, which is the x-axis, we can label distances. So I'm going to label, we should always put a scale on the axes. So I'm going to say that one square is 1 unit, so I'm labeling the horizontal axis. I'll also label the vertical axis. So this is actually a 5 by 5 grid. And then we can label all the locations. So Town Hall is at the point 0, 0. That's the center. We call that the origin for the Cartesian coordinate plane. And then we can label the other locations. So if we were to label the schoolhouse, that's 4 units horizontally and 3 units vertically. So we can give that the coordinate location for 3. The swimming pool is 3 units. I can go 3 units to the left and 2 units up. That will give it a coordinate or a location or a name of -3, 2. And finally, we have the city park. And the city park is 0 units horizontally, but 2 units down. So that's going to be at the location 0, -2. Let's go on to number 3. So number 3 says, if you were a spider, how might you name the locations in Mathville? And a spider is at the center of the web and then can go out along the threads of the web. So here we have a different coordinate system. And what would we do here? So we can say, we need to think of how we would name things. So we can talk about distance from the center, which we're eventually going to call the pole. So that would be the distance going out along these various threads. And then we also can talk about the rotation, right? So the rotation is typically done like we've been doing angles all semester from the positive, what would be the positive x-axis in the Cartesian coordinate plane. So we're going to have rotation. So let's figure out, just like the scale we set on the rectangular coordinate system, let's set a scale here. So we know that this angle here, we're going to call this 0 degrees. If we go up to the top, we'll be at 90 degrees. If we go across where the negative x-axis would be, that'd be 180 degrees. And if we go down to the bottom, that would be 270 degrees. And now let's figure out what the rotation is for each of these rays that are going out. So I'm going to count them. So we have, let's see, 1, 2, 3, 4, 5, 6. So we have 6 equal rotations in 90 degrees. So 90 degrees divided by 6 is 15 degrees. So each one of the rays that we see here is 15 degrees. So I'm going to label some of them. So this is 0, 15. The second one is 30. The next one is 45 degrees. The next one is 60 degrees. The next one is 75 degrees. Then 90. I'm not going to label all of them. This one here, I'm going to skip to 90. If I skip 2, it would be, or skip 1 to get to the second one, be 120. then 150, 180 we labeled. That's all that we're going to need for this activity. So I'm not going to write any other ones. We could always count them if we needed to. So now we want to name all of the buildings or locations in Mathville. So we have Town Hall. So Town Hall is 0 units from the pole or from the center, and its angle is 0 degrees. So this is going to be at 0, 0 degrees. So the first number that I'm putting in is the distance from the pole. The second number is the amount of rotation from what would be the positive x-axis, or in this case, we're going to call it the polar axis. So if we want to name the schoolhouse is on the ray 30 degrees. Okay, so that's the amount of rotation. And then how far out is the schoolhouse? We have a scale on the polar axis where these units are marked. So this is 1, 2, 3, 4, 5. And I can see that the schoolhouse is 10 units from the pole. So its coordinate would be 10, the distance, at 30 degrees. Let's go over to the swimming pool. So if we're at the swimming pool, we want to say how far it is from the pole and the amount of rotation. So I think it's easier to do the rotation first when I look at it. So the rotation we can see is 150 degrees here, so I'm going to write that in. And then how far is it out? So we can see we can count some of these. So let's see, this is 5, 6, 7, 8. This would be 8 right here. So this is 8, 150 is the location of the swimming pool. And then let's figure out the location of the park. So this is the park. So the distance, it looks like it is 5 units from the pole. If we go along the ray at 270 degrees, so it'd be 5. And the angle is 270 degrees.